So this is question number 3 from the paper 970142 October November 2020. Let's see the paper. Question number 3. And before solving question number 3, I would like to quote this quotation: the struggle you are in today is developing the strength you need for tomorrow. So every struggle build a strength in you. So see what we will get from this question. The energy cycle shown can be used along with suitable data to calculate the enthalpy change of hydration of calcium ion gaseous. Each arrow indicate a transformation W, X, Y, Z. Each transformation consists of one or more steps. So see W, X, Y, and you just need to observe and focus what is the transformation. See, it is W, it is X, and it is Y, and it is Z. And we just need to check that which thing is converting into which thing. So first of all, they ask for calculate the value of enthalpy change corresponding to the transformation W. Show your working. So here we are. First arrow upward indicate that calcium solid and chlorine gaseous are converting into ions, and they are asking for W. We will discuss X, Y, and Z afterwards. First of all, we want to calculate W, and for calculating W, we need to know how much enthalpy changes are involved from this place to this place. So see, calcium solid, to make calcium ion, first of all you need to atomize it. You need to make it gaseous atom. So the first energy which is required is delta H 80 for calcium, which is plus 193. Second ionization energy, second energy is the first ionization energy of calcium ion, which is plus 590. And third energy is second ionization of energy of calcium ion, which is plus 1150, and you get the calcium 2 plus ion. In a similar way, you need to atomize chlorine gaseous, and you need to make it chlorine atom. So if you take atomization energy, you need to multiply it with 2, because you need 2, you see, you have 2 chloride ion. So you make 2 chlorine atom, and these chlorine atom then converted into chloride ion. And you already know what is electron affinity. Electron affinity is energy released when electron enter into the system. And to make anion, see, first electron affinity of chloride ion is minus 349. First electron affinity is always exothermic, multiplied by 2. Why? Because we have 2 chloride ion. See, we can use bond dissociation energy, which is 242. Now, how to solve this question? To find W, we need to add all those energies which are involved from calcium solid and chlorine gaseous to calcium ion and 2 chloride ion. So first of all, we have taken plus 193 atomization energy of calcium. Then we use atomization energy of chlorine. Then we use ionization energy, first ionization energy of calcium, which is 590. And then we use second ionization energy of chlorine, which is 1150. And last but not the least, we are using electron affinity, which is minus 349, and we multiply it with 2 because we have 2 chloride ion, and we reach to plus 1477, and this is the amount of energy which is required for step W. Okay, W we have already calculated. It is plus 1477. The value of W is plus 1477. And we want to calculate the value of Z. Although we know that Z is a hydration energy for calcium and hydration energy of chloride ion, but we want to calculate the total value of Z. X is a delta H of formation, so we will write the value of delta HF for calcium chloride, which is minus 795. And in a similar way, this is the energy delta H of solution, and it is minus 83. Now, it is very simple. By applying vector method or Hess's law, this is changing into this. You can see W is converting into these ions, and these ions get hydrated and changing to the calcium chloride. See, our final destination is same. We reach to the calcium chloride aqueous. So we can reach by this way, and we can reach by this way. So we have two ways to reach calcium chloride. So we will apply the law, Hess's law. This green pathway is equal to this blue pathway, right? And by just inserting the values, it is in green pathway we have energy minus 795 plus minus 83, and in the blue pathway we have energies plus 1477 and plus Z. So now we need to calculate the value of Z. Now it is very simple. You can easily calculate. When you take it here, it becomes minus and minus 83 minus 795, and the answer is minus 2355, and this is the value of Z. I hope you understand. So again, this is question number 3, part 2. So in part 2, they are asking, use your answer to A1 and other data to calculate the value of the enthalpy change corresponding to the transformation of Z. So you need to calculate the total value of Z. As you have already calculated the value of W, you remember this, you add all these values and you get plus 1477. This is the value of W. Now, in order to calculate Z, you just need to label the values, label the energies or delta H of solution. As you know, calcium chloride solid converted to calcium chloride aqueous, it means it is delta H of solution. Delta H of formation is minus 795, and it is solid calcium, gaseous chlorine. These are elements in the standard state converting into a solid calcium chloride. This is formation of calcium chloride, and this we have already calculated, plus 147, and this we need to calculate it. Now, simple basic rule, path 1 is equal to path 2. This is Hess's law, depending upon if we need to reach a same place, same destination. So you can see there is a one way to reach calcium chloride aqueous according to the directions of arrow. You can see through W to Z we reach to calcium chloride aqueous, and another way is we reach to calcium chloride aqueous by simply forming calcium chloride from its element and then dissolving them into a water. So here we are, we apply this rule and we can calculate the value. And we will solve it on the board. See. Okay, this is part 3 of question number 3. We have already calculated value of W. Now this is the question number 2, in which we have calculated value of Z as well. In first part we calculated value of W and then we calculated the value of Z. Now again please remember that we have heat of solution, we have heat of formation, W we have already calculated, Z value of total value of Z has been also calculated. So as you know that Z is a combination of two enthalpies, calcium 2 plus ion hydration energy and chloride 2 chloride ion hydration energy. So we know the total value because we have already calculated, and you know we also provided with the hydration of chloride ion. See, it is given, it is minus 364. Now how can we calculate? It is very simple. Calcium 2 plus hydration energy plus 2 into minus 364, which is chloride ion, because we have 2 chloride ion, we get total value we have already calculated. Value of Z is minus 2355. So by just multiplying we get minus 728, and by adding these values together we get the answer minus 1627 for calcium ion. Okay, I hope you understand this question. If you have any problem you can ask. Okay, Allah Hafiz.